Yeah. Hello everyone. Yeah. How are you guys doing? Yes. Hello. Yes. Hello. Yeah. Let's wait for a few seconds, few minutes for everyone to join. Hi. Yes. Hello. Hello. Yeah. So let's wait a few more minutes for everyone to join. Okay. Yeah, so welcome to the session. So today we are going to talk about DevOps. We'll go through Docker Compose, what Nginx is, and then I'll give you a walkthrough on how to deploy a site on a VPS. And yeah, finally we'll set up CI/CD pipeline to automate the whole thing. Yeah. So yeah, that's the gist of this session that will be like taking place today. Yeah. So uh, let's wait for a few more minutes for everyone to join, and then yeah, I'll get started with it. Okay. Yeah. Let's get started with the session. Let me present my screen. So yes. So let's see. So today we'll be talking about getting started with DevOps. Let's get started. So let me explain you the problem first. So before I directly explain Docker, let me first explain what problem Docker is trying to solve. Let's imagine I build an app in PHP or some obscure language and some obscure version of Linux. And maybe I have a specific PHP version installed, some extensions, some packages, and some random stuff I did while developing. And now I want to share this app with my friend, but like he's on Windows and like he hasn't heard of PHP. So like, how do I get that to him? So for example, I send the app over to him, and he managed just to install PHP. But then he realizes, okay, it's not the right version, and then he tries again. He gets the right version, and then he realizes, okay, there's a specific Linux package I need, which is not at all available in my OS. So how do we solve this problem? Because the code alone is not enough to uh, solve the problem. The app also needs the correct environment. It needs the right package versions, the extensions, the correct version of the correct environment variables, ports, and stuff like that. So the real problem becomes, how do we replicate the same environment in his machine? One way to solve this is using virtual machines. But machines, they are heavy because they run a full operating system from they basically emulate the hardware. They run the full kernel underneath the operating system, above your operating system. So it gets really heavy if you're trying to set up multiple versions of the app. And for you will have to first install the VM, which takes a lot of space, and then you'll have to set up, which you'll have to start the VM. This startup time is a it takes a significant amount of time for a VM to start up. Yeah. So another way is we can use Docker. So Docker is basically something that runs on top of your kernel. It's not a full operating system. It basically emulates your, it basically uses the same kernel and it uses some special Linux functions, special Linux functions to isolate the environment. So your programs feel like they're running in another operating system while they're running in the same operating system. Yeah. So, and the reason why Docker is so good because it has really fast startup times and it's much smaller. Yes, and it's significantly easier to use because a VM you would have to first get the VM from your friend, and then you'll have to open the VM, and then you'll have to go to some specific file he's saved. While in Docker, you can just pull the Docker image from a registry and then directly run the app, which takes like barely 10 seconds. Yeah. So to understand what Docker is, we'll need to understand Docker file, a Docker image, and uh, containers. Okay, so let's see. So what is a Docker file? Let's start with a Docker file. So a Docker is basically a file where we write steps needed to set up and run our app. So for example, in a Docker file, we can say what image to use, what ports to open, what commands to use, stuff like that. Yeah, stuff like that. We can tell, okay, I want to start with this uh, operating system. I want to start with Ubuntu. Then I want to install Python, this specific version of Python on it. And then I want to install these dependencies. And after that, I want to open these ports. I want to have these environment variables. And finally, once everything is done, this is the command needed to start it up. Yeah. So Docker file is basically like the DNA of the is basically like DNA. And once you run Docker build, uh, the Docker runtime goes to the Docker file and it creates an line by line and creates immutable image from it, a immutable snapshot, which is basically of like a packaged result. So this image has everything needed to run your app. And with this image, you can directly push it to registries like Docker Hub, GitHub registry, and stuff like that. Yeah. And so once you have this image, now with this image, you can run multiple containers. When you run an image, it's called a container. So if you use Docker run and the name of the image, it creates a container from it. Yeah. And this container, each container you can is basically a live version of your running app, basically, which is created from this immutable snapshot and which you created by using Docker build on a Docker file. Yes. So do you guys have any questions? Uh, any questions? Hello. Yeah. Just give me a thumbs up if you guys understood. Okay. Yes, your thumbs up. Okay. Okay. So let's instead of like explaining this, let's go through a backend docker. I've created a sample app for this session. Let's go through that. I've created this app. Let me first try to run it individually and show you how it looks. Yeah. So let's go to the front end. I'll have to do npm.dev, and then let's go to the back end. And let's see. I'll do python app.py. Before that, I'll have to source into this. Yes. Now my app is running. It's a basic dashboard type app. Let's see. Yeah, this uh, basically the API returns three fields and it basically displays those. And if I close the API, yes, it returns backend online. This is just a basic app to show containerization. Yes. So now I want to Dockerize this app. Let me first start with the backend. So to Dockerize, let me create a Docker file. In this Docker file, let's see. Let me start with what image I want. What do I want to start with? So, uh, for example, normally you would start with something like Ubuntu, and then you would install Python on it. But instead of that, I'm going to directly install Python. So the from command is used to get an image. You can write from Ubuntu or from Node or something like that. So I'm going to get Python, and then after the colon, whatever I add is a tag. For example, I can type latest, which would give me the latest version of Python. But for our use case today, we'll write 3.13. I'll be using Python 3.13 today. Uh, okay, so after that, next thing I want to do is I want to set a working directory where I'm going to install this app. So let's see. Let's set it as work dir slash app. So what is work dir work directory basically? So basically, when I spawn my app, it spawns in the root. Like, let me just show you. It spawns in something like this, and for example, if it's a big app and I've copied stuff like my source folder and stuff like that, it there might be conflicts and stuff like that. So it's basically I create an app folder here, and this basically tells that any command that will be run inside this app folder from now on. So whatever command I type now on will be run inside this app folder. Okay, so the next step is I'll copy the requirements.txt, which is basically the requirements my app needs to install. Requirements.txt. Yes, to this. Yes, close this. Requirements.txt, and yeah, the copy command is used to basically copy files from here to my VM. And notice we use work directory app, so any file which I copy will be copied to the app folder. So next command which I will run is pip install minus r requirements dot text. Yeah. So this command run basically executes any command. You can tell it to download stuff. You can tell it to run stuff. If it's a build step, you can tell it to, yeah, basically do anything. Yeah. So I installed. And after that, I'm going to uh, copy over the rest of my app. So yeah, so you'll notice like why didn't I copy everything at once? Like I could have done copy uh, this, and then I could have done run pip install minus r requirements.txt. Yeah, yeah, but that would have worked. But I'll tell you why this is better, because caches each layer. So for example, it'll come here. For example, my if my requirements.txt is really huge. And okay, wait, let me explain it in a better way. So, for example, Docker goes through the Docker file while building the image, and it sees, okay, nothing has changed here, so it starts from here. So nothing has changed here, nothing has changed here. Once it detects a change, it rebuilds everything below that change. So, for example, let me first go through this case. If I would have done something like uh, yes, something like this. Yes. So if I would have done something like this, uh, for example, yeah, it would copy all the files. And then if I would have changed something in my requirements.txt, it would have to install the whole requirements.txt again. Even if I change a single line in my app.py, which is not even related to requirements.txt. So to avoid that, we do this. So only if my requirements.txt changes, it installs this file. And like this is a really good, this is a good practice that you do for like any file. If you're doing a if you're doing an React app also, you do npm install first, and then you copy the rest of your files, because the node modules that can get quite huge. And if you just change the single component, you don't want your Docker image to install all the node modules, because that's like an unrelated like change, and it takes a lot of bandwidth and time. Yeah. So after I copy all the files, and notice all the files inside this folder, the backend folder. That means this app.py require and requirements.txt. I'll be only app.py. Yeah. And notice I've made a Docker ignore. So Docker ignore is basically something which tells that don't copy these files. So when Docker will run, it will go through the Docker ignore, and it will check that it'll not copy over when, and it'll not copy over PyCache, because we are already pip installing it inside a container. Okay. So the next thing is, once it has done that, we do expose. Let's see. Yes, our app is running on port 5000. So we do expose 5000, which basically, it's not a required step. It's basically a documentation step to like tell Docker that this port is going to be exposed. Like it wouldn't matter if we would leave out this line, but like it's considered a good practice to add this, because it tells other developers and tells Docker that this port in this image, this port is going to be exposed. And finally, we run the command. We type the command that we want Docker to run once it starts. So let's type lb, and this is the syntax. Yes. So once all these finish executing, finally Docker will run this command. So let's try making an image. So we're in backend, build, and let's see, build dot. Okay. So Docker build dot will basically do this, is it will uh, scan this directory, the backend folder we are in, for a Docker file, and it will basically build that. So it'll go to a Docker file and build that. Now let's see. Once again. One second. Okay, yeah, I entered the syntax wrong. One second, let's see. Yeah, yeah, I found out where I entered it wrong. 3.13, yeah, it should be 3.13. Let's see. Yeah. Okay, so the first thing it does is it pulls it from the Docker registry, which is Docker Hub. It searches for this version and pulls this version. And yeah, Docker pulls it in layers, which means like first it will pull Ubuntu or Alpine or whatever base layer it's using. Then it will pull the Python version and apply that layer over it. Now let's wait for it to finish pulling this from the Docker registry. Okay, yes, it has completed some layers, I think. Wait, yes. Now it has set the work directory inside app. It has copied requirements.txt inside, and then it runs install requirements.txt. Yes. Now it has exposed the port. Yes. And yeah, now it has built the image. Now we can see, let's see, if we do Docker images, uh, we can see that, let's see, I built image should be here. I'll be latest. Okay. Yeah, it'll not be here. We will need to. Okay, yeah. So one mistake I did was I didn't tag this image. So before building, you generally give a name to your image. So I can give it a name like backend session, and then I build it. Now, yes. Now it you noticed it built really quickly because it used the cache, which the already built cache. Now let's see Docker images, and yes, we can see our image. And now now if you want to run this image, now we have an image. Now if you want to make this a container, we basically do Docker run and this image. Now, before running this image, we would need to expose a port. We would need to expose, let's see, we were using the port 5000. So we would need to tell Docker basically that map the port 5000 to my laptop's 5000. So now if we run this, this should start up and we can see in localhost 5000. Wait, once again, I think my screen seems stuck. Wait, okay, wait, let me just present my screen again. Use, let me present it again. Yes, yes, I guess it should be fine now. Okay, yeah, so basically where I was at is we built this Docker file. We went line by line, and after building it, after creating this Docker file, we build the Docker file using Docker build, and minus t basically gave the Docker the image its name, and dot basically gave the file where to look for the Docker file, the image where to look for the Docker file. So once it was built, we ran the Docker file and we gave it the port 5000 and we mapped it to the file port 5000, and this is the name of the image. So let's see. So let's see if we go here. Yeah, and this we are running using Docker. And for example, I can give it any port. I can give it port, let's say 80. If I give it port 80, it will, I wouldn't need to add any port. I would just do this. Yeah, it's running on port 80. So now let's move on to the front-end Docker file. We have created the back-end Docker file. Let's, okay. So let's start with the front-end Docker file. So the first thing is we will need an image. Uh, for front-end, we're using Node.js. So I will get, yeah, this image. Node 24. I think that this should be the correct image. Just check. Yes. So similar to before, we will set the work directory to be /app, which means every command run after this will run in this folder. After that, let's see, we will copy package.json. Package.json is basically requirements for text. It tells an app uh, what to uh, how to install, what all packages are needed to install the to run the app. Let's see, copy package.json. What is this head type? So this asterisk basically tells it to copy these both files. Anything after the asterisk is like copied. So yeah, so this these both files are copied, and after that I run use the run command to run npm run build. So this builds the package, and after this we will copy the whole all the files. Yeah. So yeah, the we did it again in two parts because we want to make use of Docker's caching. So if we just change anything in, let's say, uh, if we just change the simple style, we don't want Docker to go installing the whole package.json again, because installing package.json takes time. Yeah, time, resources, like internet bandwidth and stuff like that. Yeah. So after this, we expose the front end port, which is basically it's not required, but it's like good documentation. So we basically expose, yeah, 3000. I think, yeah, front end is running on port 3000, and then we finally we run the start command, the command which will be run once Docker, uh, once we run Docker, we run the Docker run command. Yeah, so npm start basically runs the Docker image. Yes. So similar way we can build the Docker, we can build other front end image, Docker run -p. This time we mapped the front end to 3000, and no, we have to build it first, right? Yeah. So let's build it uh, front end session, and yeah, we give it the context of this directory, which basically means that search this directory for the Docker file. Yes. So now first thing it'll do is it will pull node from the Docker registry, which is basically a place where you can upload your images which you create. For example, this front-end session image which I'm creating right now, I can upload this to Docker registry, and other people can pull it and use it. Yes. So yeah, let this finish. Let's, Okay. Yeah. Okay. Yeah. So we had to do this. Yes. That's just a small nuance. Yeah. Okay. So now if we run it, let's see. Okay. Yeah. It's set for this, right? Yes. Now if you run it, you can see it cached the first and the second step. Okay. Wheat is not found. Okay. Yes. So we missed, yes, we missed npm install. Let's see. Yes, this is in the wrong place. Yes, I ran the wrong command. Okay. So after package.json, it installs the package. It installs all the packages. It copies over the rest of the files and it builds it. Yeah. Yeah, this is the correct. Okay. See. Okay. And then we can run Docker run. Let's see, what did we name this? We named it front end session. Same thing we can do. We can run it in like port, let's say 2000, and the real port it's running is 3000. So we would have to go to port 3000 or 2000, and it maps to port 3000 of this Docker image. Let's see, and we give the image name front end. Wait, yes, front end session latest. This should be correct. Yes. And yeah, no. So if we go to localhost 2000, we should have a front end. Yes, we have a front end running. Yes. And one more. Yes, let's exit that. So, yes, that's basically this. And yeah, that's as I told you, with an image you can create multiple containers, and yeah, image is a safe package. We can upload it to Docker Hub, the GitHub registry and stuff like that. That's yeah. So now the next issue. So if you're running, and if we make a front end, we make a back end, we wouldn't want just to access it just using the ports like localhost 2000 or localhost 3000, because like that's not really how it works in like real production, because you haven't really seen any websites which have like google.com colon port 3000, 4000, and stuff like that. So what's the solution to this? Yeah, and here's where like Nginx comes in. So let's imagine both of our front end and back end are exposed. Users would have to access like server IP 3000 or name of the website 3000, name of the website, yeah, 5000. And yeah, and like you would tell, like why would people need to access the backend? Let's take another example. Maybe you're running two front ends, maybe in two different ports. Like in port 3000, you're running a different website, and in port 4000, you're running a different website. So that would like get messy because people would have to remember basically ports. So here's where Nginx comes. Uh, Nginx is a powerful tool. It can act as a reverse proxy. It can perform like load balancing. It can rate limit in one place, and yeah, it routes a request before between services. So reverse proxy is basically that something that sits between the client and our application. It basically sits between like us and our application, and yeah, and instead of the browser directly communicating with like say a front end or a back end, it first goes through Nginx. So we can set Nginx to do stuff like rate limit. So a user can't send more than like 100 requests per minute. We can set Nginx to do that, or we can have like multiple backends running. So we can tell Nginx to route the request to the backend which has the least amount of traffic, stuff like that. So yeah, so how does Nginx work is basically we have another configuration file for Nginx. So whenever we send a request to Nginx, it first checks in its file. If we send into something like, let's see, uh, Google, let's take example of google.com. If we send something like google.com/xyz, it will go to front end, or google.com, it'll go to front end, because the slash doesn't match API, so it goes to the next lower level, which is slash. So anything google.com/abc will go to the front end. But if we do something like google.com/API, Nginx will detect the API keyword and it will forward the request to front end. So anything after API, google.com/API/XYZ, that request will also go to the backend. So let me show you how Nginx works. So yes, this is the config file for Nginx. Basically, the first line is what port to listen to. We generally listen to port 80 for HTTP and port 443 for HTTPS. The HTTPS config would get a bit complicated, so I've done just the HTTP config. So after that, I define the slash API route first. So um, Nginx will go every time a request hit, Nginx will go through this file line by line. It'll first see that okay, if something is slash API/XYZ, it will route this request to the backend. And if something is just slash, it will route it to the front end. And like why I haven't, another question is why I haven't put the slash first is because, for example, if the slash was first, Nginx would go through it, and even slash API would match slash. That's why I put slash API first. Yes. So yeah. So now the next thing is yes. So yeah. So we have learned what Nginx does. It's basically something that sits between your front end and back end, or whatever services you have, and basically acts like a guard. You can do load balancing, rate limits, multiple like security policies, and routing, of course. Yes. So now let's talk about, okay, we have the front end Docker file, back end Docker file. Now what's stopping us to deploy it? So one thing that's stopping us is, okay, so we have now three services to run. Now running three services is, yeah, it gets a bit hectic because we will have to manage ports for each service. We'll have to manage environment variables. You'll have to manage like names and like startup order and stuff like that. So yeah, that gets complicated because yeah, we have services. Now imagine, okay, you guys might be telling like three services might be easy to manage. Like I can just do Docker and front end, Docker and back end, and then I can do Docker and Nginx. But okay, now let's say I have a database, I have a cache, I have backend has like three workers. I have let's say an AI service, and I have like multiple other services like for logs and stuff like that. So yeah, that gets complicated real quick. So a solution to that is Docker Compose. So Docker Compose lets us define the whole app in one file. So instead of running everything one by one, I run it inside Docker Compose's network. It's so file and Docker Compose might get confusing because they might sound similar, and like you see it might do similar things, but the difference is it orchestrates everything. It starts services in the order like you describe it to. It you can add like health checks. You can yeah, do many things. Let's write a Docker Compose file for this app. So the Docker Compose should be defined in the root, and yeah, the name is yes. Basically, you have to type Docker Compose .yml. Let's start. So to write Docker Compose, you first write services and then you indent, because this is an YAML file which basically works in an call in an indentation system. So our first, we have three services: the front end, back end, and Nginx. So let me start with the front end service. So for front end, we need let's say yes. So firstly, we will use the build command, which basically tells it that look into the front end folder, and whatever Docker file is that there, just build that Docker file. Yeah. So that's what this build command will do. And yeah, we can eh, like define many other things. We can define ports, we can define uh, environment variables, but we are not going to do that today. Let's keep it simple. Now for the backend service. So the backend service is going to be similar. We will do build, and yes, we'll use the backend folder for building. Okay, the next thing. Now for Nginx, notice we haven't defined a Docker file for Nginx. So what do we do? Yeah. So I've not defined a Docker file because I wanted to show you guys that Docker Compose can act as a Docker file in some sense, in some way. So we can use, firstly, it has different syntax though. We can use the image command to basically define what image are we going to use. I'm just going to use the latest Nginx image. Is this, yes. And after that, I'm gonna, let's see, use ports. I'm gonna define the ports to be, yeah, 8080, because yeah, that's a port for HTTP, and that's the port we defined in the Nginx configuration. Let's see. I think we have to indent it once more. I'm not sure. Okay, yeah. Let's come back to this. Okay. So after this, we will have to define. One second. Yes. Yeah. Now volumes. What is volumes? Volumes are basically something, files or folders that you pass from your operating system or your desktop over to Docker. So I can't physically go inside the Docker Compose and tell it that and give it this right. So I will attach a volume, basically saying whatever is in this file, add it to Nginx. And also another thing is Nginx expects a config in a certain place. I will let me just write down that Nginx. Let's see. Yes. So the first thing is telling that check this Nginx folder and the default configuration and map it to the Nginx folder in, I think it's etc Nginx conf.t, and default con, and at the end I will write read only, which basically means Docker can only read this file. It can't modify this file because we don't want something inside the container to make unnecessary changes to this file. Okay, so yeah. So that's it for the file. Let's try running this file. So to run something with Docker Compose, we do Docker Compose up and build. Let's see. Okay, we have to be outside. Yes. See, our Docker Compose file is in this directory. So now if we run this, okay, services. Okay, yeah. Okay, yeah, the way I've defined ports is wrong. Let's see. Okay, it should be like this, right? I think this is expect. Okay, yeah, define. I have to do another indent definitely. Wait a minute. Services, DevOps session. Let's see. Okay, yeah, should be another, but let's see. Nginx, images, ports, and yes, not sure why this is happening. Yes, okay, this does. I think it's problem with the Nginx image ports and okay and AT. Okay, yes, here's where I messed up. Yep, now it should now yes. So notice it started pulling the Nginx image first because the front end and the back end, the Node and Python image were already cached by it. Yeah, see, it's using the cached versions. And see, it has started Nginx, the front end and the back end all at once. Now for this, we can add health checks. We can add like startup order that, uh, for example, if you're using a DB and if you're using a backend, we don't want the backend to start before the DB because if the backend makes a request to the DB and if the DB is not there, there will be like an application error, and we don't want that. So and yes, so let's see. This should just open once we type localhost. Yes, we can see our app running. We have just typed localhost, which in real life can be something like google.com. So notice like you're not using any ports. Yes, and it's all running with one command. And now let me just shut down this container. Yes, so yeah, that's Docker Compose. Now, our app is running in a laptop, but users can't access my laptop. Like, I can technically make users access it like by opening up my router, but yeah, I wouldn't want to do that. So that's where a VPS comes in. It's a private server. It's basically a Linux machine with a public IP address, and in this session, I've already made initialize the VPS with Docker Compose, and stuff like that. Before doing that, I will just quickly add it and commit this to GitHub. So I can access this app on my VPS. Let's see. Uh, Feed and Docker files. Push. Yes. Now let's go inside the VPS. Now, if you see this, I'm inside another server. I've assisted to it, which means, yeah. So this VPS is basically a server somewhere in the world. that's which has a public IP address I can use, and I can use this to host my website, which is running 24 by 7. Let's see. So I have I have this on GitHub. So now let's just pull this on my VPS. Git pull origin. No, it's git clone, right? Yeah, let's just clone this app. CD DevOps session, and let's do Docker compose up. Yes, this will take some time because it has to pull the images. Notice like this was really fast. I didn't have to go inside each folder, install the apps, and worry about stuff like what ports I want, what environment variables I have. Like app doesn't have environment variables, but think of a really big app, like a production grade app. You wouldn't want it wouldn't be this simple if I did this manually, if I manually copied over the files and went to each directory and ran the app. Let's finish. Wait for this to finish. Mm, So I'll answer. Does anyone have questions while we wait for this to finish? Hello, Chirayu. Hello. Let's wait for it to finish. I think it's almost done. Yes, you can see it's almost done. Let me Now this app is deployed on some server. Now, if I take the IP address and I type it in the browser, I would be able to view my app. And this app is running 24 by 7, so I don't have to stop or do uh, like even if I close my laptop, this app will be running. And yeah, so now I have this IP address and I can map this IP address to a domain. Like I can map it to something like ioshk.dev, which yeah is a domain. I can map it to that. But yeah, I'll not show you how to map it in this session because we have to move on to the next topic, which is automating this. Because every time I make a change, I don't want to SSH into it. I don't want to pull the code and then again run Docker compose up because yeah, because any if any step breaks, if I miss any step, it will like break the whole deployment. And like I want to run tests, I want to see if there are any type check. If I want to run tests, and I want it to be like if tests don't pass, I don't want it to deploy. Yeah. So for that, what we do is run CI/CD, which is basically CI basically means continuous integration, and CD means continuous deployment. But for this session, you guys need to remember is CI means check if the code passes all tests, linting, it doesn't have any linting errors, type check errors, if the formatting is good. And CD basically means after everything passes, deploy this to a VPS. So in a real project, a CI pipeline might run linting, run type checking, run formatting, build the application, or build the Docker image. The goal is simple. So before deploying, uh, make sure the application works. So we don't ship a broken application out to our users. If something is like broken, we want to find out immediately, and we don't want to deploy that version to production. So let's see. I will. So for CI/CD, we are going to use GitHub. So basically, CI/CD runs on GitHub servers. It basically there's a let me make the folder GitHub, the folder workflows, and file deploy.yaml. So basically, this file defines what needs to run when a CI/CD runs. So let's create the CI/CD configuration file. So first, let's start with uh, a name. It's basically going to be CI/CD DevOps session. Yes. So next thing is we define, okay, when do we want this CI/CD to run? It's gonna be on push. So whenever we push to the branch, which is, let's say, we can define multiple branches, but let's say I'm only going to define when we push to the main branch, we are going to run this file. So we can have multiple jobs. We can have a job for building an APK. We can have a job for like testing. We can have a job for like packaging it for multiple distributions like Linux, Windows, Mac OS. If it's like an app, if it's like a desktop app, we can have it do like literally anything. But for today, we are just gonna test it, and if the test pass, we are gonna deploy it. So for the first thing, let's start with CI. So for CI, we first have to define where what does it need to run. We are gonna use Ubuntu and the latest version. I think it's like this, yeah. Ubuntu. We can also use Windows. We can also use Mac OS, but for simplicity, we are gonna use Ubuntu because our VPS is Ubuntu based. Okay, so now let's define the steps which run in this CI job. So the first step will be basically download our code. So yes, check out code. So let's just give this. So yes, so this uses the checkout action. So action is basically some predefined commands GitHub has given us that can be used to like do multiple things. It can be used to download Python. It can be used to SSH. It can be used to like switch into our code and stuff like that. So we basically check out into our code. This is the name of the action. After checking out into our code, we don't have actual tests. So in place of tests, I'm gonna just check if our Docker image builds correctly. Build let's say backend Docker image. I'll do a space. Yeah. And let's see, uses no, we don't have to use this. We have to run this command. So this is basically Docker build and DevOps backend, and we build it from this backend folder, this backend folder, yes. And we do the same thing for printing, front end and front end. Yes. So this is going to be any our CI. And normally you would add stuff like it will run some tests, it'll run type checkers, but yeah, we haven't defined anything like that. And to keep it simple, we are just gonna try building a Docker image, which is also good because it catches syntax errors and yeah, stuff like that. And After CI, I would let's run a CD job. So normally these jobs are run together. They are run concurrently. But we don't want that, right? We don't want a CD to run while a CI is running because what if this deploys before a CI finishes running? So we would write this that it needs CI, which basically means one only if CI finishes running, then CD will run. And it's gonna be the same thing, steps, and this is basically gonna be how we deploy to the VPS. Deploy to VPS, and this uses okay. Yes, so this is an SSH action, which basically allows us to yeah SSH action, which basically makes it simpler for us to SSH into the machine. 1 point. Use the yeah 03 action. Let's see, we'll use that. And now I've already gone and defined some environment variables, which include like the IP address, the SSH key, and stuff like that. So we in GitHub's environment variables. So I can just use those. So let's see. I can do something like okay. So the host is this is basically gonna be my IP address. It's secrets dot. Let's see. I've defined it over here. I don't remember it exactly. Actions. Yes, I've defined it here, the SSH key and the user. And okay, after host, we define a user name and we define our secrets dot server. And this action will automatically fetch it from the environment variables and use it. Key and let's see secrets dot server user. Okay, great. So once we have done that, once we are inside the machine, so once we are inside the machine, we first run. Let's see. Let's define a script that we have to run once we're inside the machine. So first, we change directory inside to a DevOps session directory. Basically, let's do this. So it's DevOps session. So once we are inside this DevOps session directory, let's pull the latest changes from GitHub origin main. And once we have pulled it, let's restart Docker compose up -d -build. -d basically tells it to run in background. Yes. And I think this should be, yeah, this should be it. We can add and commit this git add dot github git commit -m feed add workflow git push. Yes. Okay. So now let's see. Okay, CI didn't run. 1 second. Oh yeah, I named the file wrong. 1 second. Let's go back to this. Yeah. Yes. Yes, I named this file, I mean folder wrong. Let's see. The Is the GitHub workflows. This should be correct though. GitHub slash this work. I'm not sure. Let's see. This has, yep, this deploy workflows are at GitHub.workflows. Yep, one second. Yeah, so pretty sure this should run as GitHub. I think there will be a syntactical issue. Dot GitHub C minus this minus A. Dot GitHub is defined correctly, and we go inside dot GitHub workflows is defined correctly. So okay, let's see where our error might be because yeah, this should work. Maybe it's might be related to the extension. Deploy dot no, that shouldn't matter. Let's see. Run 1 second. Uh, let's see. I think it might be related to the name. I'm not sure, but that shouldn't matter though. Let's see. CI/CD runs on. This all is correct. Dot git commit sm fix workflow. This should run. Okay. Not sure why this is not running because yeah, it should. Okay. Then there might be a syntactical yes. I think it might be this. Let's see. Yeah, I think it should be this. It's at yes, same work message. I think it's we didn't define a branch properly. Let's see this. Okay, yeah. Hmm, not sure. Wait, let me. Let's see. I think I might have missed a syntax. There will be a syntax error. Pretty sure of that. Let's see. 1 second. I'll have the deploy file here. Let me pull up the deploy file I made before this and let me just check the syntax. I'll go to that and yeah, check the syntax. Because this should be working, yeah. Create run first, CI runs on. Yep, this everything feels correct. Let's see. Uh should, yes, okay. Yep, now it started. Okay. I'm not sure. I think GitHub was having some weird bug. Okay, I wanted to go through the CI, but yeah, so you can see it checked out the code. It built the Docker image and stuff. And yeah, let's see, our CD failed for some reason. Let's see. SSH failed to authenticate. No, okay, no key found. I think we wrote a SSH server user. Yes, we switch the places. Server user. Yes, now this should work. See, it's good that it didn't deploy in a broken config because we don't want that to happen. Like, and it tells you that if something has failed, then you can go and see the reason why it has failed. Workflow, push, origin main. Yes. Now it will again start the, yes. See, it has started the CI. Yes. Let's go ahead and change something from front end. So let's go to main.jsx and let's change something. Let's change this. Yeah. No, welcome to the DevOps session. Yes. So I've changed it to, well, let this finish and let's go to where we deployed a website. Yes. Yes. Now it's restarting the server. Let's see. Okay. It again. Wait, was it this? Yes. Let's see. It again failed for some reason. I know not. Okay. It couldn't find the directory. That's because, let's see. That's because I capitalized this. That's this CD, yes, because it's in lowercase. Let's just add the Sam fix flow. Let's see. Okay, I've also committed the change, so you can see that it's not the previous change which was there. And yep, now this should work. Let's start. Hmm. Yes, yes, it started. And it's running the CI. Once it finishes this, yes, it has run the CI. Now let's see the CD. Yeah, it has SSH into it. It's now deploying. It has pulled the file and okay, it failed in build. Okay, yeah, this should work though. Not sure why that didn't work. Git add git git commit. Yeah, So now this time it should work. It was an error with the Docker Compose. Now let's wait for this to finish. Okay, Sia has started. Yeah. Sia is almost done. Yes, let's build now. Wait for CD. Yes, this has started deploying. This just ran Docker Compose up and it's starting the virtual machine again. I think this is localhost. Yes, this is our machine. Yup, and it started. And you can see the text which I changed, which was previously not there in the VM. So this was a text I changed here, and yeah, and I pushed it to the VM, and it automatically deployed. So from now on, I can just whenever I make a code change, for example, let's say whenever I make a code change, like I type GDB session, and I can just do add commit add GDB session push, and this will automatically deploy my website. Like I wouldn't have to go to the VPS. I can just think about coding, and like we have like fully automated the process. Yes. So yeah, that's it. So this was the GitHub Action CI/CD flow. CI basically checks, it builds the images and checks it, and if it fails, it stops it there, and if it passes, it Docker Compose, it pulls it from GitHub. Docker Compose restarts all the services, and Nginx, it starts Nginx, and it starts the front end and back end. Yeah. So let's wait for this to finish, and let's wait for the text to change, which I've just put it here. So yeah, does anyone have any questions while we wait for it to finish running? I see. Should I go? Yeah, okay. Let's see. Did this finish? Yes, and it's almost done. Deploying to the VPS. It has started deploying. It's using like everything from the cache because all the packages and stuff are already downloaded. So it's like super quick and it has finished. So now we see the text changed. And this is a URL that anyone can access. This is not just running on my laptop. So like if you guys type out this IP address, you guys will also be able to access this. Yeah. So yeah. So basically, that's it for the session. We learned about Docker. We learned about Docker Compose, what Nginx is, and CI/CD. We learned how to deploy stuff to VPS. Yeah. So yeah, that's basically the foundation of DevOps. And but DevOps has a lot more to it. We used it in a specific use case here, but you can use CI/CD for building an app and packaging it into exe files for some downloaders, for installers, for packaging it into a APK, stuff like that. And yeah, so uh, my side, thank you everyone from joining. Thank you everyone for joining. See you, yeah, late again, like when we bring many sessions. Yeah. So